Hey again, YouTube. Welcome back for some more 8-bit shenanigan train wrecky wire things. So we're back with the Neo 128 that lives inside a standard 128 case. Not the D, but the normal one. I was calling this one the D Slim. I think I alluded to that on a video thing at some point where I built this stupid little thing. It's not stupid. It's just kind of ugly. It's an ugly little thing. So this is a Pi1541 hat. This is Stephen White's design. I took his schematic and made this little board. A 7406 or 7407 buffer IC, level shifter, and a bunch of pins, decoupling cap, and a couple of pull-up resistors. That's all that this board is, and a whole pile of wires and resistor leg cutoffs and stuff that I used to make it. It was a grueling pain in the butt, and I burnt myself more than once, but it works. So, fast forward to today, I did a thing, and our friends at PCBWay helped me put it into actual production here. So we have my very first PCB that I designed and had made, and we're going to install in place of this big, ugly, hand-wired board. So, yeah, I hope I got the traces in the right place and it works. We will find out here shortly. I've taken the liberty of building one already, just to make life a little easier. And, yeah, these are just the little level shifters you get off AliExpress for, this little blue board you get for a couple of dollars for, like, a 20-pack of them or something. They're ridiculously cheap. This is a 7406. I actually used a 7407 on this board, so we need to make a change in the config for the Pi, just to tell it that, we're inverting or not. And, yeah, a couple of pins, a couple of resistors that, on the 128, I'm not entirely sure how much you need, because the clock and, clock and data lines actually go through this resistor pack here, right by the, this is a 7406, I think, up there. Yeah, that's the 7406 that runs the data bus in this machine. And, the IEC data bus, I should say. And this is a 1K resistor pull-up, so I'm not exactly sure why Steven calls for them on his design, but I put them on there anyway, and save a little bit of board room. We did them vertical mount. I always thought they looked cool like that anyway, so yeah, we'll take a peek at the design, and then I need to refresh myself on the pinouts anyway, because I kind of shifted a couple of things around, and we'll get this thing plugged in, see if it works. Alright, so here's our little board. I finally learned how to use KiCad. If you're looking for advice on how to get started with this, like you open a program, you see a blank page, and you're like, oh my god, where do I begin? Go find somebody else's design. I'll put this one on GitHub, or just go pick any other KiCad. There are tons of them out there. Just pick one up and start playing with it. That's all I did. And after a week or so, I started designing all kinds of stuff. This was the first one I did, and it's done, and I had it made, and you saw it in my hand. But I got a couple more cooking as well. So it's real easy once you get rolling with it. So anyway, yeah, it's super simple. You have a 7406, you have your level shifter, a cap, some pins on the bottom, these are female ports on the bottom for the pins that are on the board, and these are the pins that will fan out on some DuPont jumpers over to the Pi. And that's it. I mean, you draw some lines, you tell it what it is, like this one's going to be 5 volts, or this one's going to be a tension or clock or whatever, and it's done. It's super, super simple. There's one or two things I may have done differently now that I've learned, like I might have used a fill for ground all the way around instead of just building a little rope of ground around everything, but yeah, all in all, I'm thinking it's going to work anyway. We've grounded our unused gates on this chip, because you're really only using a couple of them. You got 4 extras. If you ever really need to use this gate for something, you could slice that little trace there with a razor knife and use it, but you want to ground those things to keep them, less noisy and just floating. So, yeah, so that's that. And a shout out to our friends at PCBWay, obviously, who sent me the board, and you always hear the ads from all the different makers and whatever, but here we're going to do something a little different that I had not seen in somebody else's ad, And there's a plugin for KiCad for PCBWay. So you install this, now you have a button. You know, there's this whole plugins thing. I don't know, it was tools preference, wherever it is, it's a little plugin thing, right? So you get this extra button, you hit the button, it fires up a browser, it uploads the Gerbers, everything's there. You can just go basically pick what color you want it to be. Here, you want red ones? And save to cart. Log in and pay for it. Next thing you know, they're in the mail. So any KiCad files you find out there, you can just open them in KiCad and click go, and it magically shows up. These guys made it way too easy for people who have no idea what they're doing to get a circuit board made. So highly recommend PCBWay. They've been very, very helpful for all the other boards I had made already that were other people's designs, and I'm glad to say I finally contributed something back to the community. So it's something very small and very simple, but there's good things coming. So I have bigger and better projects that I'm starting to cook. So this is all it is. We have to go wire it all up. It already is wired for the prototype board that I made. I did swap a couple of pins around. I moved power over to the end, so we will go shuffle some wires around, plug this thing in, and see if it works. Oh yeah, and we gotta make some config changes on the SD card, so we'll do that too. Alright, while I've got screen caps set up, we'll do the config changes. So this is options.txt in the root of your Pi1541 card. So right now we have been using without inverted outputs because we were buffering with a 7407. I don't have any more of those, and I was going to leave the prototype board alone, but I do have 7406s. So when using an inverted buffer, like a 7406, you change that to a 1. Very, very simple. Then we're going to do a couple of other things too. We are going to add... which one of these? It's a 1306. I don't recall. Let's, oh, if it doesn't work, we can change it easy enough. Let's go with the 128 by 32. I believe that is the screen I acquired from our AliExpress. The screen is going to be upside down, so we'll leave this flipped. I had this uncommented already from the last time I was screwing around with the screen on this thing, I guess. So we are going to flip it because the screen is going to be upside down the way I intend to plug it in. And we are also going to add a rotary encoder. So there. Alright, we should be ready to do a 7406. Let's go get the board swapped out. Alright, let's get this bad boy whacked in here. And hopefully my audio is better. I played with some settings, so hopefully it doesn't sound as crappy as it has. Here's our board. All assembled, soldered, level shifter 7406, cap pins, pluggy on the bottom. So the plug on the bottom, I had to cut this out of 40-pin strip, which you always lose one. You sacrifice a pin every time you cut one of those. You always cut one pin over, and then I got a little file I'll kind of smooth it out with. But it's 6 pins across and then 2 pins up and down on the end, so it's a total of 7 across, really. But yeah, enough about that. Put a little shout out to Stephen White on the back of here too, because he's awesome. Without him, we wouldn't have this awesome little contraption. So, alright, the one thing I did change was 3.3 volt and ground. I shifted all the way to the end on this board here. And it's all silk screened on there, right? Can we see that? Yeah. So I just need to move those to the end and slide those two over, and then everything else should be a 1-to-1 match. So let's see if I can do this without screwing anything up terribly badly. We'll move these first ones that I know are just 1-to-1. There, easy enough. When I'm done, I know this works. I might crazy glue all these together so it keeps together as a little plug. I've done that in the past with good success. And then the white one is going to our, can we see that? Yeah, the white one is 3.3 volt coming out of the Pi. That's what we're actually driving the level shifter with. So we don't have 3.3 volts anywhere else. And that should just pop on like that. And then these two, I believe I just shifted directly over. You know what? Here, we'll do them. Oh, that does not make me happy. All right, I know where they go. Here, let's go. Those two there. And these two here. Yeah, we really need to crazy glue all this shit together. Come on, buddy. Are you too good for your home? Go home. Here we go. And there and that. And then, I know the board just barely clears the Pi Pico SID there. Yeah. Hey, look at that. That locks in pretty good laying on top of the SID like that too. So, yeah. I think we have a winner. As long as the electrical part works. So, alright, onward and upwards. I also did take the liberty of plugging in a rotary encoder already. And we screwed him right where the modulator port would be, or the S-video port on this particular modulator replacement. Thanks to the Australians for that. Go check him out. Is he on there? Yes, the Retro channel. Go check him out. That dude's awesome, even if he is Australian. I'm allowed to say that because I live in New Zealand. But yeah, now we have rotary encoder with a little pushy button, so we can control disk images without actually having to use the browser. This, I think, will hang on the wall. And I've also taken the liberty of wiring up, here, we'll go over here, a little harness of sorts. These are all crazy glued together already. And these are the pins to drive the OLED screen. And where did these come from? So it's pin 3 and pin 5 is your I2C bus. And then power and ground, I believe, are the other two. Yeah, the orange is the ground, and then this is 5 volt power. I was reading about those, this rotary encoder, the KY040 is what it's listed as all over the place. They come in various shapes and sizes, but it's the same encoder. They actually run off 5 volts, which I found surprising. People were saying if they fed them with 3.3 volts, it usually worked, but sometimes they would have some odd behavior. So this actually does take 5 volt into the rotary encoder, and it's supposed to be completely safe for the Pi and everything. So go figure. We'll see if it smokes it, but everything I read said actually run this off 5 volts. So, alright, I will see if we can finagle the case back on here. Alright, here's our case with, let's do that, an SD extendy thing on a ribbon cable, and the OLED screen kind of squeezes right in there, and it almost sits there, and the pins come through the bottom. Let's see if we can do this. The pins come through the bottom just enough to where you can sneak those DuPont connectors in there, and it should just hold it there. Don't worry about the tape, but it should just hold it there. The tape has nothing to do with it. It should just plug right in and hopefully just hang out and work and play with us. So I will probably, let's see, how do we want to do this? Can we just pop the hood, so to speak? And I got to remember which side is ground. Alright, ground is on the right side. And can we do this on camera without destroying anything? My orange pin is the ground pin. The yellow is the 3.3 volts. The OLED does need 3.3. And then blue and green are SCL and SDA, I think they're called. So yeah, that should be a screen. And then we can plug that into our little Pi. And power LED and keyboard. I think we'll be able to take this thing for a test run. You know what, call me paranoid. I was just about to close the case and plug this thing all in, but let's plug it in. Oh, hang on. Before we put the case all completely back together and see if smoke comes out of the new board. Because, yeah, you never know. I could have done something really bad. So, first time I'm turning on one of my own circuit boards. Well, it turned on. Is our OLED screen doing anything? No. Oh, the plug fell out. Oh, I must have picked the wrong resolution. That does not look right at all. But it turned on. Alright, let me change the resolution in the config file on that screen because that looks janky. Hang on, we'll be right back. Alright, I changed the config for the OLED to the 128 by 64. Make sure it's plugged in. Our SD's plugged in. Alright, let's smoke check. Alright. Nothing is smoldering. We have OLED. Encoder's not working. Alright, well, we know it doesn't smoke. Let me double check all the plugs on everything in here, and we will get the monitor turned on and take it for a test run. Alright, I think we're ready to take this thing for a spin. We're hooked up to a capture, and click. Alright, the machine didn't boot, but oddly, that's normal. And it looks like the rotary encoder doesn't like to work when the machine doesn't boot. But this doesn't boot because of how I have the Z80 timed, and that's a long and convoluted story for another day. Give it a reset, it usually comes back. And it did. And we have a ready prompt. And as you know, the 128 likes to try to auto boot, so it probably is okay with whatever we have plugged into the IEC bus. So, alright. We can go up and down. We can, here, let's pick a demo. Sure, whatever, EOD. Oh, yeah, and we can do auto swaps now. You couldn't do that without an interface before. If you have to go into the file browser, you know, in software, when you're running headless, so to speak, no OLED, no encoder, then you're kind of screwed when you have to swap a disk. So we can do that now. This should load our images. Then we can scroll up and down. Okay. Alright, so we're on disk 1. This is a 64 mode thing, so let's go 64. And it works! Yes! I made a thing and it works! Holy shit. I know, it's tiny compared to a lot of the awesome projects that are out there in the community, but it's my first one. I had to start somewhere. So, okay, let's make this thing go and see if it really goes. Yeah, I think it's gonna work. Alright, change disk. Sweet. It absolutely works. I'm so happy I made a thing that works. So, yeah, cool. I guess that's it for today. But I have other designs I've already started in KiCad, and some of them are a little smaller, and one of them is much, much bigger. So that's you know what? Hey, I'll show you. Hang on. We know the demo's running. We know this thing is working. I'll show you what I'm working on, and kind of a teaser or something. So yeah, all right. Hang on. Let me go back screen cap. All right. Can you see my screen? How many of you guys sit on conference calls all day, and how many times do you hear that? All right. Here's the thing we looked at already. So this is another little project I was working on. I mean little. This thing's tiny. This would be here, let's turn off some of the silk screen stuff. This would basically sit where ferrite beads do on the 25407 C64 board. And if, this is specifically ferrite bead 23, right? If you remove that bead and replace this and bodge in some power, this would buffer the clock signal from the VIC to the CPU. And the reason for that is the Kawari. And if you've seen any of my videos on 6502 timing and all that other stuff, Phi 0 versus Phi 2 and all that other crap, there's corner cases where you run into problems because of a weak clock either going into the CPU or coming out of the CPU. So this would hopefully, I got to take some measurements, but I'm hoping I can squeeze this little board down to be not much bigger than a ferrite bead with a single gate on the bottom that would just straight up buffer the 3.3 volt Kawari clock and output a 5 volt clock, which should make the 6502, 6510, whatever you want to call him, would make him a lot happier. You could also place one of these on the output of the clock. There's another ferrite bead, I forget what name it is. It's directly to the right of the CPU. That's where Phi 2 leaves the CPU and goes into the board. You could put one of these either side so you're buffering in and out. And if you're having timing issues with things like the RAD is notoriously bad about timing, the RAD REU, or the Ultimate 2 cart, if you have a bunch of SIDs in your computer and they're loading down Phi 2, you might run into problems. There's a lot of reasons why Phi 2 can get a little pissed off on you. I'm hoping this buffer could help with that. So still need some work. I want to squeeze it down, make sure it's really going to fit. I want to see if I can do something a little more creative than just have to run 2 wires for 5 volts and ground. So more to come on that, but something I'm working on. The other thing I'm working on, and this is probably way bigger than anything I should possibly take on, is, here, I'm calling this the 250666. There's a lot of alcohol and Iron Maiden involved in this motherboard, but this is an ATX footprint for a 25407 based board. I know there's an ATX 64 out there already, and there's some things about that design I didn't like. Namely, it uses the Super PLA from the 64C. And as a result of the Super PLA and the newer VIC and everything else, you run into, again, timing issues. And I did not want a Super PLA-based machine because those chips, yes, they're very reliable, but you're not getting any more of them. Where something that's actually based around the original PLA, you can get plenty more of. Plenty of replacements on the market, GALs, right? And I'm even looking at a GAL here. This is Henning's reprom circuit, basically. So I would reprom the PLA, and then I also have some GAL configs going to replace U15 with another GAL, and that would drive all your chip selects and allow you to address many SIDs. So that he would decode D400 500, bring it down here, and he would bust it out accordingly to the rest of the SIDs. Maybe he's D400, D420, 500, and 520. I'm thinking some jumpers in here to help config it. But look, this board needs a lot of work. Reset's not done. This is all the amplification for the VIC. Needs a power section. I'm thinking the side projects lab board would be good for that. The VIX section isn't done yet either. This thing needs a ton of work, but I do have the logic wired up. I have the ROM and CPU mostly wired up, and the expansion bus. This is kind of cracked out, but think of it kind of like an ISA bus. If I did this right, these would line up with ISA slots in an ATX case, or expansion slots. Shouldn't just call them ISA slots. Just showing you how old I frickin' am. But these two slots would act just like the original cart slots on the Commodore, with DE and DF going to pin 7 and 10 for addressing, and then the extra addresses D600 and D700 I would run to these other slots. This would be good for a modem and a something else. I'm thinking an 80 column card. I have an idea for putting a VDC on, or even like a CGA controller out of a PC, right? There's no reason you couldn't put one on a card, address it as D600, and make it do things. So yeah, I have a lot of really cracked out ideas, and I'm starting to put them onto this board. Replacing resistor packs with an SOIC type module. So this will replace resistor pack 3. I've already done that down here for resistor pack 4. So yeah, I mean, this is still very much a work in progress, but when I'm done with it, I can click this button and PCBWay will make me one. So check those guys out. Check out KiCad. Go make a board. And it's very gratifying. So anyway, I'll stop rambling. Everybody's probably closed this video by now anyway, but thanks for tuning in. I hope you enjoyed my first little creation that actually got printed to a circuit board. So take care, everybody, and more stuff to come. We'll see you next time.